These are the first notes for Chapter 8, where we will be talking about confidence intervals. These are the 8.1 notes, so we're going to go over the basics in these notes. To start out with, how is this chapter different than what we did in Chapter 7? Well, in Chapter 7, which was about sampling distributions, we pretended to know the true population parameters. So we pretended like we already knew what P was or what mu was. And then from there, we asked questions about possible values for, a sample proportion, P hat, or a sample mean, X bar. But that's not really realistic. They don't pay statisticians to make estimates about sample statistics. It really goes the other way. In reality, you don't know what the true population parameters are. You just have sample data to make inferences about these true population parameters. So in Chapter 8, we have a little bit more of a realistic application in that we're going to begin with sample data. So we'll have a sample proportion or a sample mean. And then we're going to ask questions about possibilities for population parameters. So P, the true population proportion, or mu, the true population mean. So let's start with this vocab term here. What is a point estimate? And why is it called a point estimate? Well, a point estimate is our single best guess about a population parameter. For example, our best guess for P, the true population parameter, would be our P hat, whatever we got from our sample data. Same thing for mu. Our best guess for mu would be our sample mean, X bar. A couple things we know. It's almost certainly going to be a little bit off, right? It's very unlikely that your sample mean is going to be perfect and be exactly what the true population mean is. So we can expect variability on that end. So what do we do? How do we deal with this variability? If you know you're most certainly going to be a little bit off with your sample mean or your sample proportion, right? They're not going to give you exactly what the true population parameters are. So our solution for that is we'll create an interval of values. So we're going to use an interval of values, and that's where this confidence interval idea comes from. That's going to be built on our point estimate. So we're going to take our sample data, whether it's P hat or X bar, and we're going to build off of that an interval of values. So what is a confidence interval? Okay, well, when we start talking about confidence intervals, we know it's an interval, but it's an interval of plausible values that we might expect for a population parameter. So a confidence interval is an interval of plausible values for a population parameter. How do we get that interval? Well, the idea is actually really simple. We take our point estimate, whether it's our sample mean or sample proportion, and we got to give it a little wiggle room. And by that I mean we have to do margin of error. So we could go plus minus some margin of error, ME. So that's how we're going to build these confidence intervals. So what is the margin of error, and why do we include it? Well, ME, margin of error, is how far we expect our sample statistic. It's how far our sample statistic, which by the way, that's either X bar or P hat, how far we would expect that sample statistic to vary from the population parameter. So how far would you expect to see a sample mean away from mu? Or how far would you expect to see our P hat away from P at most? So margin of error kind of sets out a certain distance. Like how far would these sample values fall from our true population values at most? And we'll definitely have a way to calculate that as well, right? That's not something we're just going to guess at. One note I'd like to add, margin of error does not mean bias, right? In general, margin of error is not a bad thing at all. It's just we know we can expect some variability in our results, So we're going to create an interval based on some certain margin of error that'll allow us just some wiggle room. The next piece here, how do you interpret a confidence interval? That's a very common question in AP Stats. You'll see it on tests. You could probably expect to see it on the AP exam. Interpret a confidence interval. And I'm going to give you a cookie-cutter approach that will not fail you if you outline it correctly. So you'll notice I'm going to put this in quotes. If we're interpreting a confidence interval, every time we are blank % confident that the interval from whatever the interval goes to, from blank to blank, maybe it's from 9 to 100, right? I'm not sure what it is. I'm giving you a cookie-cutter approach that you could fill in with the actual values from the problem. So we are blank % confident that the interval from blank to blank captures the true population, whatever it is, right? We'll need some context there, whether it's the mean or the proportion. So this is just where you put the confidence level. A common one would be 95% confident or 99% confident. This, you just give the interval values, right? The lowest value to the highest value. And this one, you just need to say whatever the parameter is, whether it's the true mean or the true proportion. That's what you fill in here. So in purple here, that's very important. You can use that and you're going to get full credit anytime you're asked to interpret a confidence interval. So example 1 here says, according to a Gallup poll published on January 9th, 2013, a 95% confidence interval for the true proportion of American adults who support the death penalty is 63%, with a margin of error of plus minus 4%. This estimate was based on a random sample of 1,038 American adults. Interpret this interval in context. Okay, so as far as our confidence interval goes, we've got 63% plus minus 4%. The 63% would be our point estimate. So they must have gotten a p-hat of 0.63 when they did their survey. So 63%, that's our point estimate. And then the plus minus 4%, that's our margin of error. So to build this interval, the math would actually be really easy, right? 63% plus 4% would put us at 67%. And then 63% minus 4% would put us at 59%. So those would be the upper and lower bounds for our interval. Let's go ahead and make our statement, though. How do we interpret this in context? So we are blank % confident, and the confidence level here would be 95%. So we are 95% confident that the interval from blank to blank, and again, remember 63 plus 4 or 63 minus 4, that gives us our lower bound to be 0.59 and our upper bound to be 0.67. What does it do? It captures the true proportion. And we're almost there. One little bit we've got to mention is the context piece. True proportion of what, right? So context means use words from the problems. So this would be the true proportion of Americans supporting the death penalty. So you'll notice that cookie cutter approach is present right here. And then the next part's a little bit different, and I want to give you a cookie cutter approach for this also. I want to give you something, some structure that you can get these questions right, because this is another common question. How do you interpret a confidence level? So not the interval, but the actual level. Like in this case, it was 95% for the level. And then, in other words, what does it mean to be 95% confident? When you're making the statement, what does that mean? So how do we interpret the confidence level? So in green here, if we were to take many, many samples and calculate many, many intervals about blank %, this is actually where the confidence level would go. So about blank % of the intervals that we make, or we'll just say of the intervals, will capture the true population blank, whatever that is. So you can use this outline for any time this question's asked. And all you have to do is add the context and add the confidence level. So in this case, to be 95% confidence, you would just put 95 in there for the confidence level. So I'm hoping you kind of recognize this outline from the simulation approach, right? So chapter 7, we did sampling distributions. We had to simulate many sample p-hats or x-bars. So this says if we did this approach, right, if we took this approach many times, we made many intervals, and we actually calculated these, about 95% of those intervals would end up capturing the true population, whatever it is, mean or proportion. And we definitely have a simulation that goes along with this too, so we can kind of visualize and illustrate what's going on with the confidence level. All right, the last piece of these notes, example 2, it says a large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day on average, the company provides a pedometer to 50 randomly selected employees to use for one 24-hour period. After collecting the data, the company's statistician reports a 95% confidence interval of 4,547 steps to 8,473 steps. So that's the lower bound for the interval, that's the upper bound. And this interval is supposed to capture the true mean number of steps that employees are taking each day. So let's use that to answer part A. Part A says, interpret the confidence level. So this is the one we just went over. The confidence level means like, okay, you're claiming you're 95% confident. What does that mean? That's a really high level, actually. What does that mean to be that confident? So we're going to take that simulation approach, right? If we take many samples, and you can just write it once, right? I just emphasize with an underline, and calculate many intervals. So if we did a sample a bunch of times and we calculated this interval a bunch of times, about 95% of our intervals will capture this true mean value. True mean what? We got to give context here, right? True mean number of steps per day. For what group? Well, to be clear, it's just for the employees at this company. So in black here for part A, this is confidence level. What does it mean to say you're 95% confident? For part B, this is a different question, but we talked about this also. Well, I'll do this one in purple. Part B says, interpret the confidence interval itself. So the interval would actually be this number up to this number. So if we use that outline, right, that structure that we talked about, we could say we are blank percent confident. Well, we know in this case we're talking about 95% confident. We are 95% confident that the interval from blank to blank, okay, and the interval itself actually is this 4547 number to 8473. Captures the true, what is it? The true mean number of steps per day for what group? For employees at this company. So that gets us our points for the context piece as well. So it's very common that you'll see these questions back to back. Interpret the confidence level, like in part A, or interpret the confidence interval, like in part B. And we got to make a distinction between the two and be able to answer them both. All right, so I'm obviously out of room here, so I'm going to clear this off and go ahead with part C. Part C says, what is the point estimate that was used to create this interval? And then what's the margin of error? So if this is our interval, the point estimate should actually be smack dab in the middle of that. So what's the sample mean we used, or not we, I guess the statistician used, to get this interval? Well, it's got to be exactly in the middle of those two bounds. Right? If this is the upper bound, this is the lower bound, the point estimate would have to be smack dab in the middle. So how do you get the number between those two? The sample mean must have been, well, add up the two bounds, right, upper bound and lower bound, add those up, and divide by 2. What number is exactly between those two? So we have 6,510 being the value that's between those two. So that would be our point estimate. In this case, that would be the sample mean that the researcher got. So at this point, we're really working backwards. We started with, we know what the interval is. We know the upper bound and lower bound. And we said, what's the point estimate? What's the one that's smack dab in the middle there? That must have been the sample mean that the researcher used. And then for the second part here, what's the margin of error? Well, if 6510 is smack dab in the middle here, the margin of error would be the distance from the middle to the edge, right? The upper bound or the lower bound. So in orange then, for the margin of error, we know it's the distance from the middle to the edge. And I'm talking about the interval, middle to the edge, whether it's the upper bound or the lower bound. So there's a couple different ways to figure this out, right? You could probably guess, well, what's the distance from 6510 to 8473? You could probably figure that out pretty easy. So we could just take 8473 and subtract 6510. That would give us 1963. That would be our margin of error. The other way, I guess you could take the lower bound and subtract 6510. That would give you minus 1963. But that's okay, because the margin of error is a plus-minus thing, right? So either way, I'd accept it. That's okay. The other way is just, if I just said, what's the margin of error? You know it's point estimate plus minus this value. So if we just take the difference between our two bounds, we just find the distance from the upper bound to the lower bound and divide that by 2, right? That would still give us our value, 1963. So a couple different ways to find margin of error. Whatever you're most comfortable with would be fine. All right, and then for part D, it says recent guidelines suggest that people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guideline on average? Explain. So I'm going to use blue for part D. And just right from the start here, does it seem like to you this would be something that they're reaching on average? So we're going to take our interval, and we want to know, does our interval provide convincing evidence that they aren't meeting this guideline? Well, if you look at the values of our interval, we're actually not even close to 10,000 for our average. So that's the question you should be asking yourself at this point. Is 10,000 included on our interval? And the answer is no, it's not even close. So if 10,000 isn't on our interval, and keep in mind, our interval is supposed to be an interval of plausible values. So if it's not on our interval, then we wouldn't consider 10,000 to be a plausible value for the true mean number of steps, mu. Right? This is our interval of plausible values right here. If 10,000 is not on there, I mean, heck, it's not even close to it. So we wouldn't accept that 10,000 is somehow a plausible value for the true mean for the employees at this company. Therefore, what does that say to us? Well, since 10,000 is not on the interval, that's the key here. Since 10,000 is not included in this 95% confidence interval, that's convincing evidence that they're not getting enough steps, right? So this is convincing evidence that the employees at this company are not getting 10,000 steps per day on average. You know, I should say not taking 10,000 steps per day on average. So that's a really common question. Here's a value, 10,000 steps per day. Based on your interval, is this reasonable? Well, let's see. Not on the interval. Nope. So I don't think it's a plausible value for mu at all, right? We have a 95% confidence interval, and it's not even on there. So that's convincing evidence that they're not taking 10,000 steps per day on average. All right, so we've talked about confidence intervals. We've even talked about how to interpret a confidence interval and interpret a confidence level, two very different things. That is all for these notes. I'll see you in class.